Hey, welcome to Spicy Astrobites. I'm Brian, and this is a 1975 Nishijin Model B Circuit Racer Pachinko machine, and it's running on Arduino. So when I originally picked this up off of Facebook Marketplace, I didn't know much about Pachinko machines. I just saw that it was in pretty good condition for being 50 years old, give or take, and the price wasn't too bad. You know, some people price these things really, really high, and so this was very reasonably priced. Once I got home, I ended up doing a little bit more research on this particular model and found that it's kind of a sought-after model from collectors of Pachinko machines, so that was really cool. I found that out through obviously some Google searches, but watching a lot of videos by Dan Welch, who's at Magic Pachinko here on YouTube. So definitely check him out. He's got a lot of great videos, lots of knowledge about Pachinko machines if you're interested in that sort of thing. So what's going on with it? Why is it running on Arduino when it's over 50 years old? Well, I mean, the age is part of the reason, right? So when I got it home, I plugged it in, the power worked just fine for about 5 minutes. I noticed the transformer on the back started getting really hot, and you could smell, you know, hot electronics, right? So that's never a good sign. And I turned it off. I wasn't too worried about the heat or anything like that, but I turned it off because I was done messing around with it. And then I tried to turn it back on later and found that the transformer wasn't working. So I replaced the transformer, and that was all great and everything, but then I found that it still wasn't fully working. And what ended up being the cause was a shorted coil on the relay that really controls all the game logic. And what makes these interesting is that exists on these machines. These are special electric Pachinko machines. So they took it up a notch in their day, where before it was just all gravity fed, all all mechanical entirely. But and with these machines, they actually added a little bit more to it. So this is actually the control board that the original control board that came on it. And so, you know, I had a few different options on how I could address this issue and get it back into playing form and working again. And that was, first was to try to rewind the coil on this relay. And because it's riveted into this frame, it didn't really seem like a realistic option, because then you'd have to feed this wire around hundreds of times, maybe 1,000 times, to build up enough resistance to get it back to spec. And you know, the way that it works is basically when certain areas in the game were hit, like certain when a ball falls in these holes here, it would hit a switch, a micro switch, which then would activate this solenoid. When it fully actuates, it moves this stepper, and that sends a signal to a solenoid to open up this main feature here. But also there's some lights here that turn on with each step of that. Each time it's actuated, it moves a connection in the back 5 times, and then everything turns off and closes, unless you hit one of these side switches, which also closes this main feature. So those are actually, like, you want to stay away from those in the original game, how it was originally designed. So instead of doing that, I decided to just replace it with an Arduino. Seemed like the right step to take. I'd like to have kept it all original just because it's cool. I'm definitely going to keep this and possibly try to rewind this coil at some point in time. But for the time being, I was just happy to get this all working together. So I'll kind of show you what I did. It's not completely done. I still have to permanently mount the electronics and clean up the wires and everything, but I wanted to show anyone who's interested in this sort of thing how I ended up doing it. So this is the back of the Pachinko machine. This is the original, probably not original from Japan, but the transformer that came with the machine when I picked it up. And you can see it's just a center tap transformer. So what that means is that it's got 2 12-volt leads and a 0-volt lead, so you can send up 12 volts up to the jackpot lights, ball out light, and you could also send 24 volts to the original logic board. So that's what these two white cables went to. This plastic here and metal, what you see here, is everything that makes the actual pachinko machine work without the electronics. What you see over here in this mess, this kind of rat's nest here of cables, is what I added to it. So you can see there's just a ton of cables coming out of this center area, and they go up to the 6-channel opto isolated relay board. So this actually controls a solenoid and 5 lights in the main play feature. So the solenoid opens up that middle feature, and then the lights come on, and that's what controls that, and that's just a power distribution block up there. So I will open this up and then show you where that all connects to. And hopefully the Arduino won't fall off because it's not really permanently mounted to the board yet. You can kind of see it sitting back there. It's got a screw shield on it. So I'm opening up the first panel here, and this is what gives us access to where all the electronics are. This is where the original control board was, and what I've replaced it with is obviously just the Arduino Uno. This is the micro switch right here that gets triggered when a ball falls through one of these holes in the front where the trophy is. And so that comes down, it hits the switch. Sometimes they get caught up there, which I'll talk about later. And then it sends it. So now what happens, and what happened before was obviously it sends a signal to the Arduino Uno, and then the Arduino Uno sends signals out to the relay board, and one of those signals basically powers this solenoid here. So this is a solenoid. You can see that basically it just has like a little plunger there. It pulls this up, and that opens the front feature. And then there are these 2 switches on either side, one right here and one right here, which are those green features on the front playfield. And those, when they're hit, the original, with the way the game worked originally, is that it would close up the main feature, and that's what it still does. But what's nice about having the Arduino Uno is that I can kind of get a little creative and do some of my own little things with the game, and I'll explain what I did with it later. Right, so if you're familiar with Arduinos, then you know that basically the way that it works is it's a microcontroller, and it has these inputs and outputs, and with it you can write a sketch, which is basically a program that tells it what to do as it loops through just constantly. So with each loop, you check to see if there's a certain input happening, and then you can send an output signal, and it just allows you to control peripheral, electronics that way. So I think that this was a great first project for me for an Arduino because it's relatively simple when it comes down to it. If a ball goes in, it hits a switch, you detect that signal, you detect how many times it's happened, and do whatever it needs to do. So on the first time that happens, you basically activate the solenoid and you activate the first light. And I'm speaking of the original program, how it originally worked, right? So that would open up, the first light would come on, the ball hits the switch again, that first light turns off, the next light turns on, and all the way through to the 5th light. And once that light turns on and off, then the feature closes and the light goes out. And I should mention that all of the jackpot functionality, that's all mechanical. That is the way that pretty much all the pachinko machines worked at the time. The only difference with this machine was that it also had this moving part and lights that were based on things that happened with the switches. The other thing, like I mentioned, is that these green switches here, so the balls just pass through. They don't go into a hole or anything, they just pass through. And if they trigger these switches, then it's basically like game over essentially. Like this will close up this feature, And that's that. Now I decided to do something a little bit different. Still, the basic concept of the game is the same. You hit the switch and the main feature opens, but I thought, wouldn't it be kind of cool if a little bit more happened? And we can afford to do that with a microcontroller like an Arduino versus what they were originally doing with that, which I think is ingenious how they built that original logic board with the stepper relay and everything. That was just really cool. It's cool to see how things were originally done and how creative people had to be at the time. So, you know, with the Arduino, you don't have to be as creative, but you have a lot more flexibility because of what other people have already come up with. What I did was basically, and I'll demonstrate it for you. The main feature, it still opens right when the first one, but what I have it doing at first is like, you know, I want to make it more featureful, more fun, more animated. And so what happens is the lights will spin and in an animated way, like 3 times, getting faster with each iteration. And it also plays through the piezo speaker that I put into it, or I don't know if you want to call it a speaker, but the piezo will buzz like a couple high-pitched noises, just kind of like a fun sound that gets added to it. So that happens. And then the thing about this is anyone who's ever played with a Pachinko machine probably can tell you this, but the main feature, main jackpot thing is like, it's very difficult to get. So like I said, you have to get down in here, and these, you know, when the balls come up out of here, they hit this and bounce back and forth and usually just go to either side of it. And randomly, seemingly, you'll get in here and get one of these. But it's very difficult. Usually you'll get into the tulips somewhere down here, which is cool because they all pay out, but it doesn't really open this up, which is the fun, kind of the fun goal of this. And so what I did was, these are kind of now good and bad. And what I mean by that is that you get these more frequently than a lot of the features in the game. So what I did was I made it so if you hit, between the two of these, if you hit them 5 times, it'll actually open up the main feature. And the other thing I added to it was a timeout to the main feature. So I didn't want something to happen to where we're playing it and then the main relay for the solenoid or the lights even is turned on for an extended period of time. So I made it so, originally I made it so after a minute, it would reset the main feature, turn off the lights. But you just don't have time to really play the game in 1 minute. It's still hard to get the balls into this center portion, even with the tire. Well, you can't get them without the tire open, but with the tire open, you would think that it might be pretty easy, but it's still pretty difficult to get a ball in there. So I made it after 10 minutes. So that would be, I think, sufficient enough to say that someone's not playing anymore, or you're just really terrible. And again, it closes after 5. So that's how that's working. And then, you know, again, if you've never seen a Pachinko machine or you're not familiar with them, this is typically like a ball out light. It's also a jackpot light. So there's 2 different lights back there, and they're operated by leaf switches, and those are all mechanical. Obviously there's power going to the switches and to the lights, but what controls when those are on and off is all mechanical through the leaf switches. So there's no like microcontroller or anything telling it what to do. But when there's a jackpot, this lights up. There's a light back between these 2. These are all solid around here except for these 2. They're kind of slightly transparent, and so those light up there when you get a jackpot. The ball out light, what that means is it would basically tell the people, the workers at the Pachinko parlor, that this machine needs to be refilled with jackpot balls at the top. And if you don't have them in there, then you start to run into problems with the whole machine not working the way that it should. One complication I ran into was with that switch that operates the main feature turning on and off. The balls would kind of get stuck there. And so that kind of presents a problem with the logic, with the code that goes into determining if the switch has been turned on, has been hit or not. Because if there's a ball sitting on it, then it could be in the state that is telling the Arduino board over and over and over again that it's either on. So it would just basically be each time the logic loops, it'll think that a ball has hit the sensor. So it'd basically sit on there and immediately be over. The game would cycle through the lights almost immediately, right? And close up the feature. So I had to compensate for that. I could probably try to replace the switch, but I really don't want to. And I think it works just fine the way it is, especially with the code that I put in place to compensate for that. Okay, so I'm going to demonstrate how this works. First, without opening this up, because I have a tulip open here, so you can kind of get a feel for how the game works. But then I'll probably have to open this up and show you, or I'm going to have to record for like 30 minutes while I try to get the main jackpot. Okay, so when a ball goes through that switch, it also, through the piezo, plays like it's not a good thing, right? With the way I programmed it, it kind of is a good thing after 5, but it's not good when this is open. So I could probably reprogram the sound to be a little bit happier when you get this and this isn't open versus when this is open and you get one of those, because when you get one of those and it's open, it's not good. Okay, so there's a jackpot. Like I said, pretty easy once the tulip's open, and that one's open. The bell that happens, that's all part of the Pachinko machine. It's all mechanical. It's what's so great about these is that they're gravity fed. It works perfectly, really, without any power to it at all. Okay, so I'm gonna pop open the front glass here. And this exposes the playfield, obviously, and you can easily cheat the whole thing. But I'll show you, since I hit this once, I should only have to hit this switch 4 more times, and it should activate this main feature here. And you'll see how I programmed it to do a little bit more interesting things when that happens. So here we go. It played like this when it opens up, so that's kind of your rewarding sound. It opens up, the first light's on. I'll just drop a ball in here and see like the micro switch. The micro switch is a little finicky there, so I'm gonna have to play with it a little bit. That one got stuck. So it gave me the 2 jackpots because the 2 balls came down, and the mechanical feature knows that there's 2 jackpots happening. Whereas the switch it's still a little finicky because if the ball rests on there, and it goes by too quickly, it won't detect both balls. So it needs like the weight of 2 balls on there. I might. That one worked okay. I might mess with the switch, maybe replace it. Maybe it just needs to be tweaked a little bit, maybe rotated a little bit so that there's a little bit more weight on the end of the switch and allows it to drop down easier. But I'm pretty happy with it overall. I think it's a really cool machine. And I'm really happy with how it turned out with replacing the main control board with an Arduino. So this was one of my favorite projects to work on because it mixed the aesthetics of a 1975 really cool vintage Pachinko machine with technology available today with the Arduino. So you could still accomplish a lot of the same logic and more with the Arduino, but you still have the playability of this 1975 Pachinko machine, and it's not overdone in my opinion. You know, it doesn't have a whole lot of bells and whistles added to it that it didn't originally have. If you liked this build, if you want to see more things like this, definitely like and subscribe. If you want to learn more about how it's all wired and put together, and you want to learn more about the code behind it, let me know in the comments. And until next time, we'll see you later.